Hello, everyone. So I bet we can all agree that Redux-like solutions such as NGRX Store or NGXS have dominated Angular state management landscape for years. And don't get me wrong, they are still really great solutions for the use cases. But with the introductions of signals, we got some fresh alternatives, such as Signal Store, for example. It has gained a lot of attention recently, and it's no wonder, because this is a very flexible and powerful library. But today, I would like to introduce you to yet another new player, which hasn't gained such big recognition, but it's still worth trying. And this is the Angular query. What can it help us with? So if you reach the very first page of the documentation, you will see exactly this. So it says that it's good with all kind of server state manipulation. But what does it really mean and how it's achieved? Yeah, we will just get to these questions in a minute. But before we dive in, let me quickly introduce myself. So I'm Krzysztof Skorupka. I live in Warsaw, Poland. I work for House of Angular, and I'm also a member of our great Angular.love community. Okay, so getting back to our topic. Don't get confused with this TanStack query. I will explain in a second. So what is TanStack query or Angular query? It's a state management library that focuses on asynchronous state, which is typically server state. So it is not like general purpose state management library, and you will also not keep all of your global state there or local state. It's not like that. It focuses purely on this asynchronous or server state. So it has one job, but it does it really well. So that's very important thing. And by the way, this is like a very broad use case, because I believe, as you all know, pretty much every application nowadays connects to some external resources. So initially, it was available only for the React, where it gained a lot of popularity. But in version 4, there was quite heavy refactoring conducted that allowed to separate query core from the framework adapters. Again, just React at that time. So really, when we are talking about Angular query, what we have in mind is the query core plus Angular adapter, which is applied on top of the query core. And nowadays, we also have adapters for the other frameworks, such as Vue, Solid, Svelte. So what about Angular adapter? So things are quite interesting here, because actually we have two. So the first one, which was implemented, is the ngneat query, and it's unofficial. It was developed by Nathaniel Basel. It is stable, and primarily it was just working with RxJS, but now it also supports signals. And some time ago, Nathaniel was also offered to make this adapter an official one, to make it a part of the TanStack query monorepo, but for some reason he didn't decide to and just wanted to keep it separate. So because of that, recently, like half a year ago, another one was implemented, this time official, and is mainly by Arnaud de Vries. I hope I spell it correctly. And it's experimental, but it's mainly because it's a part of this monorepo. So it's versioned along with all of the other libraries in this monorepo. So otherwise, it's still under the development, and otherwise, no breaking changes will be allowed, between the major versions. So that's mainly why, because it works pretty well already. And it supports only signals. Maybe it's for now, maybe RxJS support will be added later, maybe not, and we'll just rely on the interop from Angular. And with all of the respect I have for Nathaniel Basal for his work in Angular community, today I will focus only on the latter, mainly because it's the official one. Okay, so what kind of building blocks do we need in this kind of solution? So first, we need to be able to read some data. And this is the responsibility of query. So typically, this relates to all our get operations. But if you use post for reading the data from the server, that's totally fine too. Another one is the mutation, which is responsible for modifying our data. So typically, all of the put, post, delete requests in your application will fall into this bucket. And as it occurs, we also need a kind of a wrapper around it to make it all work together and also to instantiate the caching mechanism for us. So what is a query? Basically, query is just a declaration of a dependency on an external resource. And this dependency is identified by a unique key. So let's look at this example. And as we can see, we have a users component here. And what you are telling the Angular query library here is, I have this component, and I would like to rely on some external resource. It will be identified by this users key. And here is how you can fetch the users, this query function, which needs to be promise-based, by the way. And that's it. And just because of that fact, Angular query will know that our component needs this data. And as soon as it will get instantiated, it will get the data for us, either from the cache, if it's already available there, or it will reach this fetch users function, probably hitting the network, and get the results from there, and also save it to the cache under this key. So it can be later used either by this component or some other components that also need the same resource. And also, Angular query is able to track all of these consumers, which we call observers, of a particular resource. So if we have like 5 components which are interested in the user's resource, it can track them. It knows when they start and when they are destroyed. And when working with the query, especially in the template, but not only, you will notice pretty quickly that there are 2 sets of statuses, actually. So one is just status, and it's more related to the query itself. Pending means that we have no data yet, and we are just waiting for it. Error and success are pretty obvious. And the fetch status is more related to the status of the query function itself, which can be fetching if we are actively fetching the data at the moment. It can be post, for example, if we lost network connection temporarily or not. And it can be idle when nothing really happens with our function at the moment. So let's have a look on this example. So at the very top, we can see that we are checking for the isPending. If isPending is true, it means there is no data. We can show some kind of a loader, and that's pretty much it. If isError is true, then it means we have an error. We can display it. And if we go to fall back to else, it means we are in the success scenario in this case. So there are some data already to be displayed. So you can see these 4 at the bottom. We are iterating through the data, users query data collection, and just rendering user cards. But on top of that, you can also see the check for users query is fetching. So this means that we are in the success scenario, but at the same time, the function is fetching. So basically, we are fetching the data in the background. So that's why we can, for example, display checking for updates or something like that to improve the user experience. So as you can see, status success and fetch status fetching, for example, is like totally legal state in Angular query. And what are the other common options that we can use with the InjectQuery? I picked 3 because I believe these 3 will be the most common you will encounter, but there's much more. So first of all, we have stale time. And it really tells us for how long the data is considered to be fresh. So here we have it set to 15 seconds. So it means if we enter this component, then go out and get back within 15 seconds, we'll just get the data served from the cache and nothing will be refetched. And the next one is GC time, which stands for garbage collection time. And this one really tells us for how long we need to keep the data after it gets unused before we completely remove it from the cache. So the same scenario, let's say that we are getting to this component, then we get out and get back after 30 seconds, let's say. So in this case, we still have the data in the cache, so we will be presented with that. But in the background, they will be refetched because the stale time already passed. And the third scenario here is if we get in, get out, and get back after, let's say, 3 minutes. So it means that our data was already garbage collected. So basically, the data will be loaded as it was the very first time we are doing this. So no data available in the meantime. And then there is another option, which is called enabled. Remember when I told you that as soon as the component gets instantiated, then the thing starts running. So with this flag, we can control it. So initially, you see the signal is set to false. But as soon as we turn it to true, so it's not fetching before that. But after it's turned to true, then we start running our query. And by the way, you can see that to the InjectQuery, we just pass a function with the options. And this is wrapped internally in the computed. So every signal you use there, you can make sure that we'll make this reactive. So every change to the signals used in these options will be reflected in the config. OK, so what are the good practices regarding the query keys? So first of all, we always need to reflect our variables we use in our query function in our keys. And why is that? So just have a look at this example. We are loading the users by ID here. So if our query key will just be users detail, and that's it, we'll just keep loading new users from different IDs when we will be switching between the components, and we'll keep overriding the same key in the cache over and over again. So there will be no benefit. But if we put this ID as part of the query key, then each user will get its own entry in the query, in the cache, sorry. So it's like user detail 1, user detail 2, and so on and so forth. So this is not even like a good practice. It's rather like a must-have, I would say. And the other thing is it's a good idea to collocate the keys together and also to make them kind of hierarchical or prefix-based. So as you see here on this example, each subsequent entry in this query keys map is using some of the previous as the prefix. So for example, if you look at list, you will notice that the result will consist of users, lists, and filter name, which is, for example, John. Let's say it's our search term, right? So it will be users list John or users list filter Alice, and so on. And the same goes for the detail. It will be users detail 5, users detail 6, and so on. And why is this useful? Collocating the keys makes them really better to reason about and improves our maintainability. And making them with this prefix-based approach will help us further with invalidating the cache. We'll see this in a few minutes, but it's basically like that. And the usage is, of course, very simple. We just call the function we want, and it just constructs the key for us. OK, but what about the queries itself? As Angular developers, we usually don't like to put things like HTTP client calls into our component directly, or at all like do this for every component over and over again. We rather want to reuse them. So your first idea could be like this, but I will immediately say, don't do this. This is not a good idea, and I will explain you why. A few minutes ago, I told you that Angular query is able to track all of the observers of specific queries, right? And that's because when we call the InjectQuery, it's attached to the specific injector in our application. So if we call it for a component, it's attached to the component injector, and it's created with it and destroyed together with the component. But in this case, our service is provided in root. So if we call InjectQuery as part of this service and just assign it to the field of this service, this will basically mean that it will live pretty much forever until our app is destroyed, because it will live as long as the root injector lives. And so Angular query cannot really track this. There will always be one active observer. And even if we use it in like 5 different components, there will still be just one observer from the Angular query perspective. So this is totally a bad idea. Don't do that. So what's better alternative? If you really want to stick to services, you can call InjectQuery as part of some method of your service. So this way, if you call it in the component, it will be attached to the component injector rather than the service injector. But this is still error prone and also a little bit artificial, because we're just doing this to have this common user service handle. And also the invocation in the components is still a little bit verbose. So what's even better alternative? It's to create some reusable inject functions that are focused on very specific queries. So as you see, we have a set of 2 inject queries here. One is dedicated to the list, like to all users, and the other one for the user details. And as a result, our component looks very simple, and this is like quite elegant solution. Okay, so let's get to the query client. Basically, there is typically just one for the entire application. As there is only one cache for the entire application, we want it to be shared by all of the components across our app. And it's also able to accept the global configuration. So if you don't want to do this per query, or you would like to set some defaults, you can do it here. And it also acts as a primary access point for us to play with the cache. Like kind of directly, but not really. It just provides us a set of methods that are really useful when working with the cache. So here we see an example. We have a component, we inject query client, and we have the onInvalidate method. And when it's called, we are calling query client invalidate queries with the filter on query key, and we just pass this factory of users keys all, which is basically just users. So as a result, all of the queries that start with users will be invalidated. So it's users, users list, users detail, and so on and so forth. So now you see why this prefix-based approach is really useful. So in cases like that, but also we have some other filters available here, but this is definitely most common to invalidate by query key. And as I said, we set up a query client like this. We just inject it to, provide it to our application config typically, and it accepts the defaults for the queries and for the mutations. And the stale time is by default 0, so it's pretty strict. That means that as long as we enter our component and the data gets refetched, let's say, immediately it's considered stale. So basically, each time we enter the component, we will be served, of course, the data from the cache, but it will be also refreshed in the background. So that's like pretty aggressive approach here. And the GC time, garbage collection time, it's set to 5 minutes. So by default, our data from the cache will be removed after being not used by within the period of 5 minutes. Okay, and the last concept is the mutation. We can instantiate a mutation by importing and calling inject mutation. And the minimal configuration that we need to provide is the mutation function in order for this mutation to do anything, basically. So as you see in this example, in the mutation function, we are just calling the update user on our user service, and yeah, basically updating the users and all the user. And also we have a set of convenience hooks that we can use. So in this example, I used on success. So as soon as we get the response from the server that the operation was successful, I'm invalidating the queries of all of the lists and also the specific user detail. So other details of the user are not touched because they are not affected, but potentially all of the lists can, or pretty much any of the lists, can contain the information of this user, and of course the detail of this user will also be affected. And we can run our mutation by calling mutate method on the object we constructed this way. Okay, so is there more? Yes, it is. So we have plenty more concepts in the library, which are pretty easily configurable. For example, we have a query tries. So Angular query, in case of any, let's say, network error or server error rather, we'll just try to repeat the query with some quite interesting algorithm applied and like query again and again. And we can define like how many times it should do this, or like even provide our own implementation of the algorithm. We have also a very good support for the optimistic updates. In the example I just showed you, I was just updating the user and on success invalidating the cache. But it's really simple also to implement optimistic updates. So once we are hitting the server, we can already put, for example, this user to the UI, or even modify the cache and put it to the cache, so it will be reflected in all of the applications, all of the components in our applications that are using it. So that's pretty nice. Also, if you use pagination or any kind of load more or infinite scroll solution, there are also separate type of, let's say, inject queries for that purpose, and you are covered here. It's very good support for that, and you can really implement such concept very easily and with a good user experience. And for example, there is also a focus monitor. So you can even track if you switch from the window with your application to some other tab of the browser. And if you switch back, it will also refresh the data in the background. There is also network monitor. So as I said, for example, when we lose the network connection, it will just not blindly try to hit the network and send the queries or the mutations. It knows about this fact, and it just waits until the network connection is restored, and then it keeps running again. We also have some specific network modes because each application is different. Some of them can rely even on some offline resources. You can also do this in Angular query. It doesn't have so much sense, right, to use cache for some offline resources, but technically you can. So maybe you don't rely on the network at all, or maybe you have the PWA application that will just use also the service work and caching and so on. So these scenarios are also covered by different network modes implementations. And if we start combining all of these concepts, then you will see that this library is really powerful, and you can pretty much achieve any scenario you think of. But you might be wondering, if so much magic is happening with my data behind, how would I know like what's really going on there? How would I debug this and so on? So they have you covered also here. They have pretty nice Devtools designed for just for this library. And you can just import the component, put it to your template, and you are ready to go. And they look like pretty much like this. So all of your queries are listed there, and also the mutations. You can sort them, you can see the details, you see what's happening with them, what's their status, what's the data behind each entry in the cache, and so on and so forth. So it's really useful. Yeah, and I also prepared a very small demo application for you so I can show you how it works in the reality. So just give me a second to adjust my setup. Let's have a look on our application. This one is a very simple one. You can see that we have a list of posts, and each post can have a couple of comments. And we also have a list of comments. We have very simple search as well implemented for each of the lists. And yeah, that's basically it. You can see also on the bottom, there is the Devtools widget. Okay, so let me switch to the code actually. And maybe let's start with the app config. So as I said, here we just configure the application and provide Angular query just once. And yeah, by the way, this application is running Angular release candidate 2 of version 18, and is using the experimental zoneless change detection, and is working really pretty well with the Angular query, which is also signal-based. So yeah, that's cool, right? Yeah, so this is the app config, and maybe let's look to some queries we have in our application. So for example, for posts, you can see pretty much what you saw on the presentation. For the list, we have the also stale time defined for posts for 10 seconds, because we really consider our data posts usually don't change so often, right, on, let's say, blog, right? So we can safely set it to 10 seconds, and we are good with the stale time, the default one, GC time, the default one of 5 minutes, for example. Okay. So let's see the comments queries, for example. And here we expect that the comments are like, much volatile. So we define the stale time for 3 seconds and garbage collection time for 5 seconds. And basically, they are also very similar to what we've seen in the presentation and also in the posts queries. So that's pretty simple. And we have one mutation, as I said, so we can see it. This is the delete mutation at this time. So I will just show you in a second in the application. And on success, it just invalidates the list of the comments. Okay, so maybe let me also show you one of the components. Maybe let it be post component. And yeah, so this is the whole code that we need to have this kind of a list of results with a simple search, right? I just have a very simple search control here, convert its value changes observable to signal, and I feed the value to the inject post list query, and that's pretty much it. And when we look to the template, it's also not complicated. As you can see, we have this loading post, we display some error in case of error, and then there is a list of data when the query is successful. Okay, so maybe let's get back to our app because I think it's more interesting. So you see a list of posts here. Maybe let me refresh it. And I will throttle my network a little bit so you can better see what's really happening here. So let me, for example, search for some term. You see posts are loading. So it just takes a while for these results to load. And if I remove it and search again for the same term, you saw that it was like just immediate response because it was already in the cache. So that's pretty nice. And let's get to a single post. For example, you see we are loading post data and we were loading post comments. So it's already there, our information. Yeah, we have the info about the post and the list of comments. And now when I switch to the post list, I implemented a simple directive that will show us which post has already some data cached. So as I get to each of them and back, you see this is already cached. This is also already cached. And if I get back after some moment in there, yeah, you see the post information was already there because the stale time and garbage collection time was set to a bigger value because we don't expect the post to be like so often changed, right? But the comments were loading from the scratch because the garbage collection time was set to 5 seconds. So let's now get to comments. We can maybe even better see here. I will get to create post, for example, then get back, and just you see the green mark, but just let's wait this 5 seconds and it's gone, right? So it's not there at all at this point. But if I do this like more quickly and get back here, you see it's still there and it was not reloaded, only once when I get for the first time. Okay, so then another thing, for example, let's remove some comment. Let's take this one, well explained. I will remove it. You see we are hitting the network, and as soon as it's successful, the comments collection is automatically refreshed for us and the view gets updated. So yeah, it's we get it out of the box. What else can we also discuss here? Maybe let's get to the code because I've also prepared one more example. Let's get to the post component. Yeah, and for this query, we just use this enabled configuration. Maybe I will get there just to show you. You see we have this enabled. We read it from the function parameter. So let me get back to the component. And initially, I set this show comments to true, but now let's switch it to false instead. And let's, maybe I will remove the throttling so it's faster. Okay, it's there. And now I will throttle it again. Yeah, so right now you see we are loading the post data, but comments are not shown. I just put also like ngIf that if this is show comments is false, I just show the button. So only when I click it now, the query gets enabled and our data gets fetched. So yeah, so that's an example of the enabled flag. And when it comes to the Devtools, when I was switching between all of these use cases, you can notice that these things are really changing here. So for example, you see this blue color, it indicated that it was fetching. Now it's fresh. After a couple of seconds, it will get stale according to our configuration. Yeah, you can see it now. Yeah, for example, another thing we can show, it's the offline mode. So if we switch to comments now, let me clear the network tab. I will switch to comments. You will see this query is paused at this moment and no request is fired. As I told you, it monitors the network state as well for you. And when I switch back to the online state, they get fetched immediately. And also, just another example, when I switch to maybe let me clear that, to another card, and I get back, you see they are also refetched in this scenario. Okay, so I guess that would be enough for now. And that's basically it. And that's all I had for today. So thank you very much.
Okay, so thank you, Chris. But before we let you go, let's first check whether there are some questions. So maybe here on site first.
Well, thanks. My name is Alex. I'm a bit Angular dinosaur working on version 14. And my very first question, how do you think, how hard is it to implement this library into existing application?
I would say it's very, very easy. to be honest. It's much easier than, let's say, any other state management library I can think of. Maybe the one that I also mentioned in the intro, the signal store is also quite easy. But this one is really like, as I showed you, you just need to provide this query client once in your application config. Then you can just inject query in any component you want, and that's it. And what's really important, it doesn't have to be implemented for every component, right? You can just do it in like a single one when you see really a good use case for this one, and you are good to go. So it's really simple, I would say. Okay, so the question was if it supports server-side rendering and transfer state. So to be honest, that's why one of the things I have on my list to verify, because I haven't played with SSR and query and Angular query yet, but I was already thinking about this, and I believe it does, because basically if you are using HTTP client as your query function, then you should be good to go, right? Because the state of the HTTP calls will be preserved between the server and client. But also Angular query, it also has a little bit better support for SSR on React, because as we know, it's there for years already. But there is also a possibility, even if you don't use HTTP client, to kind of serialize the state of Angular query on the server side and restore it on the client side. So even without HTTP client, you should still be able to achieve this in Angular. Of course, it requires some testing of the edge cases and so on, but basically it should be working.
Hello, Krzysztof. Thanks very much for this talk. I would like to ask if there is something to consider if we are using the new deferred use API and TanStack Query. I don't know if there's anything.
I think not really, because probably the use case you are thinking of, sorry, the question was, I need to repeat it. If there is anything special we need to do when using Angular query with the defer block. So basically, I think not. So as soon as our defer block component will be instantiated, then if it has some inject queries calls inside, basically it will work the same as every other component, like, you know, instantiated through the router or like ngif or whatever. So there is no difference from the Angular query point of view.
For Motadi, and it's whether we can inject this service into the resolvers and use them there to fetch the data.
Not really, I would say, because the thing with resolvers is they also reside on the level of the injector when they are used in. So if you put them in the router configuration, they will be attached to the environment injectors. So this is very similar to the example I showed you with the injected in root service. So that's not the best idea. But if you would like to trigger the query, and also you will not have like access to this data like via this inject query then in the component. Although like anyway you have to inject it there for the like second time. But what you can do, you can inject your query client to your resolver and just call prefetch, specifying the keys you would like to prefetch for your component. And that's basically probably the use case that the person asking had in mind. So it's like when you hit the resolver, you just fetch the data and you get it. Of course, you can also implement some scenarios if you really want this to also get the data back in the resolver and use it there. But yeah, basically that's it. And also you will lose a lot of the goodies, you know, because when you are loading something in the resolver, you are not able to get to the component yet. And for example, show the user the loading state, right? So the user experience suffers. So basically, resolvers in general for such cases are not the best user experience you can achieve. You can also do this in the component.
So this possibility you said is like hit the endpoint, fetch the data, set some specific cache time, and then hit it once more in the component, and you get immediately data because you hit it a while ago in the
Yeah, so it's
resolver,
like you just did it just like half a second earlier or whatever, right?
Okay, thank you. So we have another question, whether there are some red flags in terms of using it in the project.
As I said, it's still experimental. And while I told you it's basically because of the fact that it's a part of this TanStack Query repository, and yeah, that's the main reason. Still, some scenarios like this SSR is not yet tested. As I said, probably it will be working. I've also seen some notes from the author of the library that he has to do some work also in this area to test this and so on. So yeah, you should be careful in general, but with the typical scenarios, I would say no. And maybe the only thing I can think of, if you have really data-rich application and you use the cache very extensively and you specify a very long garbage collection time, you can end up that your application is consuming more and more memory, right? Because this data needs to live somewhere, right? We need to keep it in the memory, in the cache, so it also costs something. So if you fetch a lot of data and save it for a long time, you can have pretty high memory usage.
Okay, so we will continue with two more questions. So the first one is, what is actually this cache, whether that's the normal browser cache or where this data is located?
Basically, as far as I know, it's just located in the memory, and it's like the internal implementation of Angular query, so it's not like very specific.
And what is the pros of that approach in comparing to NGRX, and maybe especially the NGRX signal store right now?
Yeah, so that's a good question, and it can be really discussed much broader. But basically, the purpose of this library, as I told you, it just focuses on fetching the server state and nothing less, nothing more, right? So you should mainly use this for that kind of things. While you can achieve some entity management and so on in Signal Store, you will not get this caching and so on by default. So basically, these are two different use cases. Of course, you can achieve that with both NGRX store or Signal Store, but you will need a lot more code to that. And as you saw, these components were really lean, 3 lines of code just to inject queries, and that's it. You have already all of the goodies I showed you.
Okay, thank you, Chris. So we'll finish with that one. So let's make, again, an applause for Krzysztof.
Thank you very much.